Okay, the last speaker between fixing DNS problems and you is Ivan, who is setting up right now. Um, we're going to talk about security. We're going to talk about delivering software faster in a secure way. Yes.
That's somehow wrong.
Is it ready? Does it look like?
Yeah, but that's my wrong screen.
That's your home screen, so we're trying to get a presentation up. Um, Ivan actually lives in Eindhoven. He's probably the one closest to the venue from all of our speakers. While he struggles with his setup, I can also read from my screen that he's currently working on projects such as Mandu, which is a full-stack security platform, and Hot Creepy, which I'm gonna let him explain if he wants to. And there we are, so good luck.
That makes sense. Hello, everyone. Sorry for hijacking your session. I believe you came here for something else, but I think things aligned nicely because we can now build up upon the other presentations that we saw so far. We're going to talk about supply chain security or how to develop quickly without inviting the Nefarious. So, a bit about me. This thing used to work, and now it no longer doesn't. So, I'm going to have to do it manually, I guess. Yes, okay. We use the keyboard. My name is Ivan. I work at Mondu. We're an infrastructure security company. Before that, I used to work at Prodrive Technologies, which is here in the area, so some people might know it. I worked there on multiple different projects, multiple different directions, different positions. But let's not talk about me, because we're here about something else. I'm going to start this with a story about innovation, because everyone here innovates and everyone likes that. This story will be about us adopting Kubernetes. I believe everyone has gone on that journey, or at least has started it. How did it start? Well, it starts with you, or me, doing our codes, writing our tests, building our stuff, managing our infrastructure, doing our load balancing, auto-scaling, all the fancy things. We have our own fancy scripts that do the deployment, and everything just works. We all have that. We have the God mode. Everything is nice, but one day this happens, so this is you, and you always meet that person, could be a colleague, could be a consultant, but they come to you and they offer you something. They say, I know you're the best at your job, but what if I told you there is something that can make your life much easier? And that's a tool like this. It does almost everything for you, and you barely have to do anything. You can focus on coding and everything else magically happens. And at that point, you're thinking, yeah, okay, but there are a lot of these things that sound nice. And you probably want to ignore the person until he shut up and go away. But there are also these people that they don't, and they keep trying, and then they continue and they show you something like this. And they're like, you know, these things that men usually like, and they're 5-in-1, you can use it for your face, body, moisturize, and whatnot. Well, what I'm offering you is more like this, so it's 25-in-1. You can also mop the floor, brush your teeth, and whatnot. It's amazing. I promise you it will make your life easier, and eventually that thing turns out to be Kubernetes. I believe we all had such experiences, so eventually most of us start experimenting with Kubernetes. Some adopt it, some might not, but this is how it goes. Of course, in every story there are bad people, and in this one we call them the Nefarious. Those are the people that we want to avoid and want to protect ourselves from. Who are they? Well, they are bad. Obviously, what do they have? Well, they are smart, they're organized, they have access to unlimited resources, which most of the part is also rich because we also know about all these government-funded teams and so on. Then, how do they operate? Well, that's also another fun story. So they operate as a business. They actually operate just like us. As a matter of fact, they have playbooks. So if we take as an example ransomware attacks, they actually have a playbook, they have a manual, they have literally the steps that you need to execute to exploit someone and lock up their infrastructure. this happens, and then you get a nice email or a nice thing on your screen that's locked up, and it has a sales quota. They actually give you a quota that you need to pay, and they don't want money, they want cryptocurrencies, and they don't want Bitcoin because it's public, they want something more private, for example, a Monero, which is very sketchy, and if you're not into these kinds of things, you don't know what to do. Well, they're a business. They have customer support. Believe it or not, these things actually have live chats. You can talk with a person and you can explain your problem, and they help you to get the money and transfer it to them. Another fun thing is they have affiliate programs. If you help them infect another company, they give you a discount on your bill. So they do operate as a business. What do they want? Well, they want to steal our secrets, data, whatever, anything that leads to money, obviously. Of course, we're smart. We have defense lines. And those defense lines are meant to protect us from these people. Now, let's see how the defense line looks like. So, we manage them, right? We believe that they're good. We know that there are some things that might be a bit leaky, but usually it's good. So, we believe that it looks like this. Pretty secure, right? Then, you have your CTO, which has a different opinion, but he actually believes it looks like this. For whoever doesn't know, this is Fort Knox, probably one of the most guarded buildings in the world. Then, if you're lucky, you have a security engineer in your company or a security officer, and they have a better understanding on these things, and they believe it looks like this. So they know you have the best archers, they have the shiniest armor, pointiest arrows, they know what they're doing, everything is nice, but if they're good, they also know that they're up against tanks, and that doesn't really work. So, what it actually is, do we want to know? Well, I think if you reflect on your infrastructure at the moment, for a lot of you people, it might look like this, this, or that. There is at least one security policy that you can find in your company that remotely resembles one of these things. I'm pretty sure about that. Then, that's the story, but if we have to be serious, this is a problem. So let's see what we can do. We can start about discussing what Kubernetes is. I believe most of you, whoever has used it, they have seen that picture. This is just all the components involved in your clusters. And of course, the more nodes you have, the more complicated it gets, which also makes your attack surface larger. Because of the complexity of Kubernetes, companies are actually picking up the cloud, because their attempt is to offload the maintenance burden to the cloud. And funny enough, they actually believe, some of them, that because they run a cloud-managed Kubernetes, they don't need to do much about security. Because, I mean, I run EKS, right? Amazon takes care of security. Why do I need to bother with it? Well, that's not the case. It's actually not secure by default. And yes, I know the numbers there don't add up to 100%. I don't know if it's readable, but that's because in that survey, people can select more than one thing. So it is correct, trust me. Let's see what we can do about securing Kubernetes. First of all, how many of you here use Kubernetes? Is this the right crowd? Okay, that's more or less right. Then the question is, how many of you can confidently say we have a secure cluster and everything is nice? Okay, one. Then I can argue when you last checked it, and do you believe that right now at this moment it's still secure? Because a lot of people also struggle with that. They do prepare for an audit, which happens once or twice a year, and then once the audit is gone, we go back to the previous stuff. So what do we need to do to secure a Kubernetes cluster? Well, if we look at it, if we take the example of managed Kubernetes, it has multiple layers. If we want to be able to say that we have a secure cluster, we need to address every single layer because, well, our security is represented by the weakest link. We start with the cloud services. So what do we need to do to secure our cloud service? Well, there we need to check our identity management. We need to secure our networks, our storage. We need to verify our encryption keys, who has access to them. And we also need to figure out what we do with the logging, because believe it or not, there are a lot of people that decide to log, for example, requests containing passwords in the cloud log. Then we have the cluster nodes that actually run our workloads, but those nodes are virtual machines sometimes, or physical machines, doesn't really matter, but they run operating systems. Well, operating systems have their own vulnerabilities. They have their own patches that need to be applied. You can have packages that are installed that can also have vulnerabilities. You need to actively check for these things because they change daily. There are known vulnerabilities released daily, and if you don't check it, well, then you're in bad luck. Then we have the Kubernetes control plane, which also requires some attention. You probably want to check whether your API server has encryption enabled. Does it do authentication? Does it do authorization? You probably want to have audit logging, so changes don't go unnoticed. And yeah, other things are, for example, etcd. Does it have encryption at rest, for example? On top of the cluster, we run our workloads. I mean, we started all this journey so we can run our workloads and remove the burden of maintenance. Well, these workloads, they also need to be configured correctly. So you probably want to set resource limits because you don't want an exploited workload to eat all your memory, for example. You need to make sure that they don't have unnecessary privileges, and you probably want to restrict network access such that bots that shouldn't communicate with each other can do that. Finally, we're at the point that we're very interested, and that's running our own application. Well, the application needs to run in a container, and containers also have vulnerabilities because they have their own operating systems, which they also have packages which you need to check, and then you have your application, which can be vulnerable as well. Now, this is already getting quite complicated because we have discussed 5 layers that are only related to Kubernetes, right? To make it more complicated, we also need to do secure development, which is outside of the cluster. Now, everyone here has seen this, I hope. I think that's why you're here. What's the DevOps lifecycle and why it happened? Well, we did that because of innovation, again. So what people strive for and companies strive for now is to innovate faster. Why they do that? Well, because whatever you do, there's at least one other company that does it, and whoever does it faster wins. Simple. What DevOps fixes is it gives you more power to do things in an attempt to make it faster. And it does seem to work because everyone adopts it, right? To speed up DevOps, we have GitOps. Now, we have discussed the runtime, but how does GitOps actually work? Well, this is a very simple thing that probably most of us here do. So we have our local development environment where we write our code, we write our tests, make sure that it works correctly, and then eventually we push the changes to our source control, and that source control triggers a CI/CD pipeline. That CI/CD pipeline will probably do exactly the same, build, test, hopefully it will do some attestation or signing or all kinds of different security checks, but eventually the end result is that our application ends up in our cluster environment. Now, we know how to secure a cluster, or at least some steps to do that. But if we want to secure also the GitOps workflow, we need to address all of these steps separately. And to be able to say that they're secure, what is going on here? Ooh, okay, too bad. I will try to fix that by just reading these things. There are some questions that you need to answer to make sure that your GitOps workflow is secure. And those are not, I would say the list is not extensive, but there are some steps at least as a guidance of what you need to do. So for your local environment, typically you want to know that your developers are actually working on a secure workstation, because if the workstation is exploited, anything can happen. These people have access to your repositories, things can get injected and whatnot. So this is one of the things. The other thing is, are your developers actually able to identify security issues before they end up in the source control? So that means that within your company, you probably want to set up some standards, like some tooling or procedures that people should execute before actually pushing to source control to verify that they're not pushing vulnerable things, such as, I don't know, vulnerable containers, or that they're not adding dependencies for open source packages in your software that happens to be vulnerable. Then we have the source control. So for that, you also need to secure it. What you typically want to do is you want to make sure that there is multi-factor authentication. Why? Well, because if someone exploits one of your people's credentials, you don't want them to be able to log in just like that. Other things that you probably want to do is you want to check that the right people have the right access. And we talked yesterday about that. There was a presentation about it. You want to give people the minimum privileges they need. They don't need broad access, probably, so you need to monitor that, and when things change, you need to adjust their permissions as well. You also want to make sure that you do trigger your CI/CD and it has as many checks as possible. Now, CI/CD needs to be secure as well, and what we mean by that is, well, you probably want to execute those security checks at your CI/CD pipeline as well. Why? Because between the time that you actually developed it locally, it got merged to your main branch, and you actually deploy it, many things change. As I already said, things are developed daily, and we also have known vulnerabilities published daily. So you need to check as often as possible. What else do we have? Yeah, we discussed the vulnerabilities. So, okay. Those are the things you should do about GitOps. Now, let's look at the current situation in numbers. As you already saw, we have a very large scale that we need to protect. And that is a problem, because if you look at this is from the State of Software Supply Chain, a report by Sonotype. It's from last year. You can see the attacks that happen year by year, and they're exponentially increasing. Why that happens? Well, it happens because we're developing more and more software, and that software is becoming more and more complicated. I mean, attackers literally have a bigger chance. The more options you have, the larger the chance to win from the lottery, right? I believe in this report, one of the main things that they actually try to analyze is the type of supply chain attacks that, for example, exploit one of your application dependencies. So someone hacks into one of those NPM packages or NuGet packages or Maven or whatever you use. They change something to just create a backdoor for them, and then people start pulling it because it takes time to actually see that this happened. And then they try to exploit those people. Now, things eventually get figured out, and people notice that change is not okay, and they announce it. And then there is a fix. But in order to apply the fix in your infrastructure and your application, you need to do something. It doesn't happen magically, usually. Even Dependabot requires you to do some small thing to actually get it to work. So, an interesting thing from the same report, but then from last year, they have this graph, which is actually showing how long does it take companies to resolve known vulnerabilities after they have heard about them. I don't know if you notice it, but this is an interesting fact. More than half of them actually take between a week and never. And that's not good, right? I hope you don't do that, but it is in the report. I am pretty sure it's true because I have heard stories about these things. And I don't know how it makes you feel, but I can tell you how it makes me feel. It's like this. We gotta do it, right? Yesterday we discussed that we want to make software secure for our kids. Well, if we want to make software secure for our kids, we need to address that graph. That's probably the main thing. Now, what's the solution? I mean, everyone is here to understand what we can do to fix it. Sadly, there's no solution. I mean, if there's one question that 42 cannot answer, it's probably this one. But there are definitely things that we can do to improve the situation and make it more difficult for the attackers. And you know, this is a game of cat and mouse. It's inevitable, things always happen, but we need to make it as hard as possible for people such that it becomes very much less tempting to even try to exploit us. And one of the things to do, which is becoming more and more popular, and I hope more people adopt it, is DevSecOps. So the idea is to push the security left. And the goal of that is that you need to identify your security issues as early as possible in your development workflow. So the earlier you identify your issues, the cheaper and easier it is to resolve them. And you also prevent situations like what we discussed earlier. Now we can read the questions. So if someone wants, can take a screenshot of this. We discussed them already, but the main thing about this is, I mentioned it earlier, you need to check it automatically and continuously. I mean, if you check it only when you have a security audit, it doesn't help. And it doesn't help because, as we already said multiple times, things change daily, even hourly. And one experiment that I heard people did is they intentionally deployed an Amazon EC2 instance with a vulnerable application with open ports, so just publicly open ports of the machine, and it took 2.5 or 3 hours for the machine to be exploited, which just proves the point that those attackers actually have automated botnet networks that actually, check for these things. It also proves a point that it is very quick and easy for an attacker to identify which system they can exploit, and then we go back to one of the first slides where I showed you that they actually have those playbooks and manuals. Because they know that if a machine has that specific vulnerability, they only need to execute these steps. And if you go on the dark web, you can find those, they're literally PDFs, you can find those PDFs. It is a step-by-step thing. Even you can do it. So if you manage to hide the vulnerabilities, maybe you're secure, but yeah, if they happen to know that you have that specific vulnerability, even a child can hack you, so it's that bad. What are the conclusions from this? Well, I hope we agree now that security is complicated, and if this is your infrastructure, I mean, it's big. You cannot maintain it yourself. And also, if you have security, it has to be applied everywhere, because an attacker's path to your secrets can look like this. And also, if we look at those hops, it doesn't necessarily need to be the case that they use the same vulnerability for each hop. It can be many different things that eventually lead to an attacker, for example, becoming domain admin in your organization. And by the time they have that, they can delete your backups, they can lock up everything, change passwords, encrypt, and whatnot. So it's really about the small things. Also, something that we discussed yesterday, I believe. Someone had that presentation where even 1% makes a difference over time. This is also a confirmation about this. Then we need to share the responsibility of security. We cannot fix it ourselves, and we need to cooperate on that. So developers, operators, and security people, they need to work together, because as individuals, we don't have the knowledge to fix all the security issues. It just doesn't happen. Developers know how the app works, operators know how the infrastructure works, and security people know probably all the vulnerabilities they need to look for. But to be able to identify them and fix them as quick as possible, we need to work together. We cannot do it alone. And last but not least, don't trust anything. Don't trust your developers in terms of if you see something committed from an account, don't believe that that's the same person that you expect it to be. Don't trust open source modules and packages. Why? Because a lot of people got burned by that, and the reason is it's very easy to just replace one letter in an open source package, and then you do a typo, it gets pulled correctly, and you expect it to work, but then you happen to have a vulnerability. Or even if that's not the case, we all know about Log4j. You need to check for these things actively. That was it. Thank you for listening. And if you have questions, please ask. There are questions.
So, questions.
No.
Start with the second one.
The second one is no. You need to fact check everything. I'm going to back up my thesis, okay? So no, don't trust me. But you can fact check all of that.
Okay. But how do you check vulnerabilities in the control plane? Assuming it's a managed solution.
So for the control plane, for the managed solution, you don't need to check anything. But your worker nodes, you do need to check. So there are different settings for your kubelets that you can alter, and you should alter to fix that. There are firewall rules, there are file permission settings that you need to check. There are plethora of tools that can help you do that, but they are not secure by default. And that's the mistake that people typically make. Also, even firewall rules that you need to check in your cloud system. It just doesn't happen. I think I checked it 1 month ago, and only, I believe, Azure had locked out the nodes from external access by default. All the other cloud providers don't, for some reason. I guess for convenience.
Basically, the follow-up, should we trust public cloud providers?
No. Also, as I said, you need to double check it. So when I did, as I said, Azure did it something well, others didn't. but the only way of knowing is actually checking it.
All right. Last one, do you recommend GPG signed commits?
Yes, sign your commits. That's one of the things that can help you identify that the actual username that committed it is the person that you think it is. I mean, it also depends how they keep their GPG keys, for example, but assuming they do it right, it does help.
The rest of the questions are philosophical discussions for the open spaces or lunch. And basically, that being said, I have no more iPhones to hand out.
Yet.
And there's lunch. See you back.